Now, let's have an example. A car moves along a straight line with a displacement vector of 275 meters due east. Then the car moves again in the same direction with a displacement vector of 125 meters due east. Determine the resultant vector. So first thing to do is to draw the problem or illustrate the problem. So below we have the figure vector A, which is the 275 meter. 275 meter due east, and vector B is the 125 meter also due east, as illustrated in the figure. And the resultant vector is from the starting point to the finish point, which is represented by vector R. Therefore, vector R is equal to vector A plus vector B. We can see that vector A and vector B is along at the same direction, which makes our problem easier. In this case, we can simply add 275 and 125. Therefore, the resultant R is equal to 275 meter plus 125 meter, which makes our resultant vector as 400 meter. So since resultant vector requires magnitude and direction, we must indicate that 400 meter is due east, as supported also with our figure. Next problem. A car moves along a straight line with a displacement vector of 275 meters due east. Then the car moves along in the same direction. Sorry for typographical error. The car moves again with a displacement. Let's erase this one. In the same direction. Okay, again. Then the car moves again with a displacement vector of 125 meters due north. Determine the resultant vector. So first thing first, illustrate the problem. So we have vector A, which is 275 meter due east, and vector B, 125 meter due north. And we are looking for resultant vector, vector R. So doing the tail-to-head fashion from starting point to finish line, this is our displacement vector. As we can see in the figure, we have a right triangle. Therefore, trigonometric functions are applicable in solving this one. So we can see now, we have two sides given 275 and 125 meters. We can solve now directly for the magnitude of R. The magnitude of vector R is equal to the Pythagorean theorem, using Pythagorean theorem, 275 meters squared plus 125 meters squared. Therefore, the magnitude of vector R is 302.08 meters. Now, since it is a vector, we have to solve for angle or the direction. So direction theta is equal to arctangent opposite side, which is 125, over the adjacent side, which is 275 meters. Therefore, our theta is 24.4 degrees. Therefore, our resultant vector is equal to 302.08 meter at 24.4 degrees north of east. Another problem. Now, this time, we will use the component method. Three players on a reality TV show are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and in a different order for each contestant the following three displacements. Vector A, 72.4 meter, 32 degrees east of north. Vector B, 57.3 meter, 36 degrees south of west. Vector C, 17.8 meter, due south. The three displacements lead to the point in the field where the keys to a new forge are buried. Two players start measuring immediately, but the winner first calculates where to go. What does what does she calculate? So first thing first, let's have the given. Vector A is 72.4 meter, 32 degrees east of south. Vector B, 57.3 meter, 36 degrees south of west. Vector C, 17.8 meter, due south. So let's illustrate these three given vector. Let's say we have here the y-axis and the x-axis, and the origin is our starting point. So the first vector A is 72.4 meter, 32 degrees east of south. Sorry, it is not east of south, rather it is east of north. Okay, so let's proceed. Therefore, we have here, okay, pagpasensyahan ng drawing, wala tayong ruler. We have 32 degrees east of north. So meaning, from north or the y-axis, positive y-axis, we will draw 32 degrees to the east. So we have 72.4 meter. Next, 57.3 meter, 36 south of west. So from the tail, from the head of vector A, it's going to be our new origin. So we will draw 36 degrees south of west. Let's say, yan. 36 degrees south of west. The magnitude is 57.3 meter. And for our third vector, we have 17.8 meter due south. So going down, we have 17.8 meter. So this is our vector C. This is our vector A. And this is our vector B. So the first two player go or do follow this direction, and our winner calculate first. Therefore, we are looking for what the winner has calculated, which is the resultant vector. So we're looking for the magnitude and direction of vector R. So we already know that using component method, by adding the x component of each vector, will result to the resultant x component, and by adding the y component of each vector will result to the resultant y component. So to solve easily, we're going to use a table. So we have distance A is 72.4 meter, B is 57.3 meter, and C we have 17.8 meter. Next, we're going to get the angle from, take note, the angle from positive x-axis. From positive x-axis. Therefore, the angle for vector A is this one, which means this is 58 degrees. For vector B, from positive y-axis, this is 216 degrees. And finally, for vector C, this is 270 degrees. Next column is the x component, and lastly, y component. To solve for x component of vector A, which is this one, this is AX, this is AY. So with this right triangle, we will use the cosine function. Therefore, AX is equal to 72.4 times cosine 58 degrees. which will give us the value 38.37 meter. And for y component, using the sine function, ay is equal to 72.4 times sine 58 degrees, which is equal to 61.40 meter. Okay, so I'm going to write here ax is equal to 72.4 cosine 58, and ay is 72.4 sine 58. Next, for the x and y component of vector b, using this figure, we can have here our right triangle, wherein this is bx, which is negative, and by, which is negative. We can use either 206 degrees or 36 degrees in finding Vx and Vy. So we may use Vx is equal to 57.3 meter times cosine 36 degrees. So with this equation, 57.3 meter times cosine 36, it will give us positive value of Bx. But take note, as we can see in the illustration, Bx is directed due west, meaning it must be negative. So we have here the clue. It is negative. So instead of using angle 36 degrees, we can use 57.3 meter times cosine 216 degrees to give us directly a negative value of Bx, which means it will give us the value negative 46.36 meter. Again, I repeat, if we use 57.3 meter times cosine 216 degrees, it will give us directly a negative value. But if we're going to use 57.3 meter times cosine 36 degrees, it will give us positive value. And we must refer to the illustration to get the right direction, which is negative in this case. For y component, Vy, we can solve Vy in the same way with Bx, either 57.3 meter times cosine 36, not sine, this is sine, since it is opposite with 36 degrees. It will give us again positive value, and we must refer to the illustration that By is directed south, meaning negative value. So if we use 57.3 meter times sine 216 degrees, it will give us directly a negative value of negative 33.68 meter. Now, for Cy, for Cy and Cx, as you can see in the illustration, vector C is directed south, meaning we have no value of x component. We can check this one using 17.8 meter times cosine 270 degrees, which also will give us a result of 0. Now, for cy, as you can see directly, vector c has only one component, which is 17.8 meter, which is along the y-axis. Therefore, our cy is 17.8 meter. Again, vector c is directed downward, therefore it is negative. To check this one, use 17.8 times sine 270 degrees, which gives us the result of negative 17.8. Now, since we have the value of x and y component of each vector, we can solve now for the resultant x and y component. By adding this component along x-axis and y component along y-axis, we can have now Rx is equal to negative 7.99 meter and Ry is 9.92 meter. To check or verify either our answer is correct, look at the illustration again. So the resultant R has negative Rx and has a positive Ry. So to solve for the magnitude of our vector R, use Pythagorean theorem. So we have square root of negative 7.92 squared plus 9.92 squared. Therefore, our resultant magnitude is 12.7 meter. To solve for angle, we use arctangent. (9.92) over negative 7.99, which will give us negative 51 degrees, which means 51 degrees from negative y-axis. Therefore, vector R is equal to 12.7 meter, 51 degrees north of west. Now, let's check your understanding by solving this problem. Again, your answer must be written in the comment section of this video.